is going to be something that's very familiar to you because we did this before when we did angle, side, side, all that. It's very much the same concept, only we're dealing with similarity instead of dealing with congruence. So as we get started, let's first talk about the fact that when we deal with triangles being similar, we need all of their angles to be the same as all of the angles in the other triangle, and we need all of the sides to be proportional. But the nice thing is there are 3 shortcuts that we can do to tell that things are similar, and the first one is going to be this angle similarity. So to be able to use angle similarity, you got to have 2 angles that are congruent to 2 other angles inside of these triangles. So in this case, angle P is congruent to angle X, maybe. We also have angle R congruent to angle Y. Now, because we have 2 angles congruent, these 2 are going to be similar to each other. It says 2 angles of one triangle are congruent to 2 angles of another triangle. They will be similar. Guys, it's not 3 angles. Even if you have all 3, it's not 3 angles. The rule is angle similarity. So we would say triangle. And if I go Q, P, R, guys, the order is extremely important when you do these. Just like when we did triangles when we were doing congruency. If I go QPR, then I've got to go Z, X, Y for my other triangle. And they would be congruent by angle, similarity. If all you put is angle, it's wrong, because angle would talk about congruency. When you don't put the little tilde symbol, the little the little similar symbol, that's going to mean that it's similar, not congruent. So please make sure you don't leave that off. Alright? So there are 2 more shortcuts. We're going to get both of those. The other 2 shortcuts have to do with sides and angles being mixed up, or just sides. Let's take a look at those. So this first one is going to be side similarity. And in order to prove side similarity, all of the sides that are corresponding must be proportional to each other. So guys, just like last night's homework, you set up the ratio for each one of the sides. You put the 12 over the 4. You put the 8 over the 2 2/3. And you put the 6 over the 2. And it doesn't matter which one you put first as long as they're connected to the right number. Okay, grab your calculators, guys. We got to divide these. Now, 2 of them, really easy to do. Guys, what's 12 divided by 4? Just 3. You can give it 3. It's not a ratio. We're not trying to give a scale factor. So if you were giving a scale factor, absolutely keep it as 3 over 1. But just 3 is fine when you're just trying to compare them. Thank you for saying that. Guys, I heard that from 2 of you. So I don't know where the other was. 6 divided by 2 is also 3. Okay, and there is a set. There should be one under there. So you're absolutely there. They're there for y'all to use. Please feel free to use that. When you're done, you just put it back under the desk when you're done with it. Okay, absolutely. Do 8 divided by 2 2/3. I hope it's 3. It is 3. Okay, good. I hope so, since we're trying to prove they're similar. So when you take a look at that, all 3 of these are the same. It doesn't matter what number they are, as long as they are the same number. Because of that, triangle, let's see if y'all can tell me. If I go ABC, what triangle would ABC be similar to? What was it? I'm sorry. DEF. Yep, DEF. Nice. DEF. Perfect. By, and then we would say, guys, what's the reason? Yes. Perfect. Similarity fine. You can say similarity, it'll be fine. SSS with the little tilde, SSS similarity. That is correct. Side. So the last one, it's the hardest for people to see. It was the hardest when we did this when we were dealing with congruency as well, because it has this thing called the included angle. Listen to me. You cannot have a random angle that's somewhere other in the triangle. You have the 2 sides right here that are proportional to the 2 sides right here. And we can show that really quick. We got to show it anyway. We might as well show it now. So it'd be 10 over 5 equals 8 over 4. So those sides are proportional because each one of those would divide and reduce to what? 2. So now, we have to have what's called the included angle congruent. So this angle that is actually between these two sides, not Q, not L, not N, not P. It's got to be the one that touches both of those sides. So angle M has to be congruent to angle O in this case. Because that included angle is congruent and the two sides are proportional, I can say these triangles are congruent. And I'm going to say it a little differently. Let's say NLM. If I go N, L, and then M, what order would the other one be in? Nice. Nice. TQO. So the reason they would be similar is by side angle side similarity. You can say SAS similarity, side angle side, tilde, just as long as you know what you're talking about when you're writing it out. Okay. Alright, anybody see anything on the rules? Guys, that's the only rules today. That's all that's new. The only thing we got to do is actually do the problems that goes with it. That's all that's new, and they're shortcuts, so they make life easier. You don't have to do all 6 things, all 3 angles, all 3 sides. Okay. So, then our problems are going to look like this. We'll have some that look like this. For the first 2, we've got this, and then for these, we're going to be doing the algebra part of it, and then we're going to talk about 7 and 8. We're going to talk about 7 and 8. Notice there's no 3, 4, because there's just too many problems. I just didn't feel like we just don't need that many. So, here we go, guys. So we're trying to decide if these triangles are similar, and this is going to involve something old. Now, listen to me. There are 2 triangles here. Some people can see it, some people can't. There's a little triangle. It's going to go G. You don't have to write this down. I'm just trying to show you. GFH. And then there's a big triangle, and that big triangle would be the big triangle of G, E, and I. Doesn't seem like a big deal, but some people don't see that they both share that angle at the top. It's the same. You see they both have G and it's congruent to itself, reflexive property. But we also have 2 other angles the same, and you should know this based on this. What does it mean when this little triangle is on both of these lines? They're parallel. And if they're parallel, corresponding angles will be congruent. I told you that's never going to go away, guys. So this angle would be the same as this angle, and this angle would be the same as this angle. So I can say that these triangles are similar. So I can say triangle, and if I go GFH, then for the other triangle I'd have to go in that same order and go GEI. By which one of our theorems? And you only say it twice. It's only angle, angle. Nice. Angle, angle, similarity. Okay. Y'all doing okay? Anything? Everybody's good on the shortcuts? Okay, so, guys, on this next one, there's 2 correct answers. Listen to me. 2 correct answers. I'll show you both. Okay, guys, the angles in the middle are the same. How do I know these 2 angles are the same? Come on, you know this. Yeah, vertical. Guys, angles that are across from each other when lines intersect are going to create those vertical angles. Those vertical angles are going to be congruent. Because of that, and because these are isosceles triangles, if this base angle is this measurement, then this base angle has got to be the same measurement, and they have to be congruent to each other. Same thing in this triangle. This is a base angle inside of an isosceles triangle. So if this base angle is here, then the base angle has also got to go over here. So for that would be triangle. And guys, the easiest way to do it is based on the marks and measurements. I'm going to go from the one that doesn't have a mark, so I'm going to say B, to the one on the outside that has a mark, that's going to be A, to the one in the middle, that's going to be E. So if I use that same idea on the other side, good. Again, no mark to the mark on the outside to the one on the inside. The one with no mark over here would be D, to the one that has a mark on the outside, which would be C, and then the one on the inside, which would be E. And guys, what would the reason be if I did it this way? Angle. There's another way to do it. There's two correct answers for this. Guys, I'm going to switch colors. You do not have to do this, but you might want to put it just kind of off to the side, that you can do this as well. Okay? You could also look at the sides being proportional. You could put the 27 over the 45, and you could put the 21 over the 35. If you divide each one of those, let me do the math real quick. What is it? 27, 95. What's it? 0.6. And 21 divided by 35 is 0.6. So you can see the sides are also proportional. And we already know angle E is congruent to angle E. So because of that, I could say the same triangles are congruent. But by what method would that method be if I'm using this, the angle, and this? What's the other way? Yeah, that'd be the side angle side. Good. Side angle side similarity. Okay? I just need you to understand that there's not always one correct answer. The only thing that has to happen is your work just needs to back up whatever your answer is. A lot of times there's more than one correct answer. Okay, guys. So the other type of thing we're going to do today is with the algebra. Don't have a panic attack when we get to example, 5? I'm telling you. No, example 7. I'm sorry. When we get a 7, don't panic. Don't panic, I'm telling you. It's okay, you can do this. Okay, here we go. Guys, I'm going to look at this outside piece right here. It's got a 10 on it. What does the outside piece on this other triangle have on it? That's got the 4. Then we do the same thing again, going in the same order. You've got to start here. Because I started with the triangle that's on the bottom, I got to start with the one on the bottom for the other side. So it would be the 2x plus 10 over this one on the top that's here, which would be x plus 3. To solve any proportion, we cross multiply. So I'm going to multiply here and here. That's going to make it 10x plus 30 equals 4 times 2x is going to be 8x plus 40. We're going to minus 8x from both sides. That makes it 2x plus 30 equals 40. We minus 30 minus 30. That makes it 2x is equal to 10. Divide by 2, and x is equal to 5. Now, all it's asking you for is x, so you don't have to do anything else. That's it. You're done. Alright? So, the next one takes a little thought, and I guarantee you this will be something you have to deal with, so watch this carefully. Guys, I need to compare this short leg right here to this long one on this side, because the triangle is not just this little piece, and we don't know these lines are parallel. We can't just do part to part, part to part. We don't know the lines are parallel. But we have to do 6 over the whole thing. So we have to add these two things together. If you need to use a calculator to add it. Whatever you got to do. But those two go together to give you 9 and 3/5. On the other side, we're going to do this short part to 5 compared to the whole thing. Guys, how do we write adding these two parts? Yes, but I wouldn't write it in that order. Just because I know we're going to factor eventually, that's what we're going to be getting to after the quiz, I would put x plus 5, just because it makes your life better afterwards, okay? It's not right or wrong, it's just going to make your life better down the road. So when we set this up, it's going to be the short piece right here, 6, over the long piece on this side, which is 9 and 3/5, equals the short piece on this side, which is 5, over the long piece over here, which is x plus 5. Good. We cross multiply this. 6 times the x plus 5. Again, if you're one of those people that you would be better off if you wrote out this part so you distribute it correctly, please feel free to write it out. You're just multiplying this times this times this. If you don't need to write that, don't write it. I don't write it personally, but I do a lot of this math. So that'd put it at 6x plus 30 equals, what's 9 3/5 times 5, guys? Is it? It is? 38? Oh, 48. Okay. I was not expecting that. Oh, because the 5's cancel, because it's 5 over 1, it cancels out the denominator. I'm not trying to question you. I just didn't think that was right. I just thought it would be a fraction. So minus the 30 minus the 30. Sorry, I wasn't trying to be like thinking you're wrong. I just didn't think that was it. Divide by 6, and x equals 3. That doesn't look like a 3. 3. Okay, so guys, that's what your homework will look like. Now, there will be 2 problems on the notes, and there'll be 3 problems on your homework where you're going to do the first part of this. You're going to do all this stuff, but you're not going to do the solving part. And there's a reason why. Let's show you why. Because it's going to require more algebra, it's going to require factoring or the quadratic formula, and we're not going to do that till after the quiz. So guys, on this one, you would set up your proportion. The hypotenuse to hypotenuse, so it'd be 15 over x equals the bottom piece to the bottom piece, so it'd be x minus 2 over 8. Okay. Now, guys, if I cross multiply this, x times x gives you what? Which one? It's x squared. Yep. It's okay. That's what it's about. If you multiply 2 times x, then it's 2x. If you multiply x times x, it becomes x squared. Just remember an old math. So x times x is x squared minus x times 2 is going to be 2x. And then the 15 times the 8, hold on, don't say it. I want to try it. 120? Okay. Now, this problem cannot be solved unless you factor it. You need to make it equal 0. To do that, we minus the 120 from both sides. You get x squared minus 2x minus 120 equals 0. And at this point, guys, depending on what you're most comfortable with, normally we would take it from here and factor it or use a quadratic formula or whatever it is that you do. Y'all might have learned like the diamond method. You might have learned to do the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. Yeah, whatever you're comfortable with, we're going to factor, but we're not doing that till after the quiz. So you're going to stop right here. Okay? We will do the last part of this, like this type of stuff, after we get done with the quiz. But it doesn't hurt to help practice setting this up. Again, we're not going to factor until after the quiz. I don't want you to stress about that. Don't try to figure that out. Don't worry about it. It is not on the quiz. I'm telling you so you can plan. Okay, for the other one, do the same thing. Oh, you're going to have to do some old math on here, though. Let's see who remembers what this is. It's going to be 39 over the x plus 6, because it's left side to left side, equals the 2x minus 4 over the 24, the bottom over the bottom. Okay, I'm writing this out the long way. Even I write this one out the long way, just so I don't miss anything, don't mess anything up. Here we go. It's going to be x plus 6 times 2x minus 4 equals, I have no idea. What's 39 times 24, guys? Y'all tell me. 936. Okay, guys, here we go. When you multiply a binomial times a binomial, 2 parentheses with plus or minus in the middle, what's it called when you do the multiplying across? It is distributing, but it has a name. Does anybody remember what that name is? No, we could try. Let's show you this and see if you get it. I'm multiplying these. Well, yeah, that's what we called it. That's what he nicknamed it, was the crab claw. It's called first, outer, inner, last. You're going to be foiling. The teacher called it foiling, distributing multiple times. It's basically distribution, but a total of 4 times. So they gave it a fancy name. You multiply the first 2, the outer 2, the inner 2, the last 2. That's where that comes from. Foil. F-O-I, maybe if I saying all right. F-O-O-I-L. That's where it comes from, guys. So I multiply the first 2. X times 2x is going to give me 2x squared. X times negative 4 is going to give me negative 4x. 6 times 2x is going to give me a total of 12x. And 6 times negative 4 is going to give me minus 24 equals 936. We need to combine like terms. Our like terms are right here in the middle. Ooh, this thing's slow. These two need to go together. So that's going to give me 2x squared. Guys, what's the 8x? And the bigger number is positive, so you put the 8 with a plus in front of it. And then the minus 24, that's not going to be a 2. I wrote a 2. Equals 936. And guys, there's one more step before that factoring part. What does it have to equal? 0. So we gotta move it to make it equal 0. So we minus that 936, minus the 936. You're gonna end up at 2x squared plus 8x minus 960 equals 0. There you go, guys. We're stopping right here. Listen to me. This is where you would have to factor or use the quadratic formula. That's going to require you to factor out a GCF, to do your diamond, to do splitting the middle term, to either do quadratic formula. But again, we're saving that algebra until after the test to kind of remind you how to do that algebra. There's a worksheet after that, like a 5-problem worksheet to kind of make sure you understand it. Okay, any questions before we move on?